Hi everybody, in this video lesson we will do some nice fun practice problems on equivalent fractions. So here's our first one. We are given this fraction over here 6 over 8 and we have to find an equivalent fraction for 6 over 8 by dividing the whole into fewer parts. So right now we have the whole divided into 8 equal parts, 6 of them are shaded and therefore we have the fraction 6 over 8. But how can we find an equivalent fraction? By dividing the whole into fewer parts. So for that, what I want you to think about is if this line here did not exist. In that case, you would have the whole divided into 4 equal parts, 1, 2, 3 and 4, and 3 of those 4 parts would have been shaded, and therefore the equivalent fraction we would get in that case is 3 parts shaded out of 4, so 3 over 4. So one possible equivalent fraction for 6 over 8 is 3 over 4. Now the next problem says find an equivalent fraction again for 6 over 8, but this time divide the whole into more parts. So right now the whole is divided into 8 parts, but we want to divide it into more equal parts. So let's do this. I'll draw a line like this through the middle over here so that each of these parts gets divided into 2 equal parts, and then also do the same over here. And now you can see that the whole has been divided into 16 equal parts. So our denominator will be 16. And how many of the parts are shaded? So earlier we had 6 shaded parts. Now we will have 12 shaded parts. So the numerator will be 12. So we'll get 12 over 16 as the equivalent fraction for 6 over 8. You could of course divide this into even more parts, but we just had to find one possible equivalent fraction with more parts, and in this case that's 12 over 16. Okay, true or false? 4 over 5 is equivalent to 16 over 25 or not? So let's see. So to go from 5 to 25, we would need to multiply by 5, but then we would also need to multiply the numerator by 5. So 4 times 5, but that would be 20 and not 16. And therefore 16 over 25 is not equivalent to 4 over 5. So this is false. Now here's our next one. It's a word problem. Bob and Peter have ropes of equal length. As we can see here, Bob cuts 4 out of 10 equal parts from his rope. So let's write that as a fraction, 4 over 10. And Peter divides his rope into 15 equal parts. How many parts should Peter cut to match Bob's length? So Peter divides his rope into 15 equal parts, so our denominator will be 15 here. But how many parts should Peter take or should Peter cut to match Bob's length? So we don't know the numerator, we don't know the number of parts, so that's what we have to find. So these two fractions need to be equivalent, 4 over 10 and this question mark over 15. So how do we find the question mark? Well, we will first reduce 4 over 10 to its lowest form. So what will be the lowest form? The GCF of 4 and 10 is 2. So we divide above and below by 2. We get 2 over 5. And now we will go from 2 over 5 to question mark over 15. So 5 times 3 is 15, and therefore we'll also need to multiply 2 by 3 and that will give us 6. So the question mark here will be 6 over 15. And therefore the answer to this problem is 6. Okay, shade the figure to show an equivalent fraction of A. So we have this number line over here, 0 is at that end, 1 is over here, and this unit interval is divided into 4 equal parts, and this point here is labeled A. So because this point is 3 parts away from 0, this corresponds to the fraction 3 over 4. Now we need to shade that figure over there to show an equivalent fraction for 3 over 4. So let's count the number of parts here. So we have, let's start from here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 parts. So 16 is our denominator, and we need to shade a certain number of parts so that we get a fraction that is equivalent to 3 over 4. So to go from 3 over 4 to something over 16, I will need to multiply the denominator by 4. As we can see, 4 times 4 will be 16, but then I will need to do the same with the numerator. So if I multiply the numerator also by 4, I get 12 over here. So 12 over 16 is the fraction that's equivalent to 3 over 4, and therefore I'll need to shade 12 of the 16 parts. So let's do that. So this shaded region therefore represents a fraction 12 over 16 that is equivalent to 3 over 4. Okay, now here's our next problem. Find the equivalent fractions for 4 over 12, one with 15 as the numerator and 2 with 15 as the denominator. So in the first problem, in the first case, we have to find an equivalent fraction for 4 over 12 such that 15 is in the numerator and we don't know what comes here. In the second part, we have to find an equivalent fraction with 15 in the denominator and we need to figure out what should come in the numerator. So the way we'll do it is, again, first reduce 4 over 12 to its lowest form. So the GCF of 4 and 12 is 4. So we divide above and below by 4. We get 1 over 3 as the lowest form of 4 over 12. And now we will go from 1 over 3 to 15 over something. So for that we'll multiply 1 with 15, but then we'll also need to multiply 3 with 15, and that gives me 45 in the denominator. So the answer to the first question is 15 over 45. What about this one? So again, 4 over 12, the lowest form is 1 over 3, and from 1 over 3 we'll go to this fraction with 15 as the denominator. So 3 times 5 is 15. I'll need to do the same with the numerator. I'll multiply it by 5 and that gives me 5 over here. So 5 over 15 is the equivalent fraction for 4 over 12 for our second question. So that's the answer. 15 over 45 for the first part, 5 over 15 for the second part. Alright, now here's our last question. Find the next fraction in the pattern. So we're starting with 1 over 5. Then the next term is 1 over 5 again. But this one is 2 over 10. This one is 6 over 30. This one is 24 over 120. So what's really going on here? So let's see. In the first, so this is a starting fraction 1 over 5. So to get this fraction, the second one, we multiply above and below by 1. Okay, so let's see. So we multiply above and below by 1 and then we get 1 over 5. Again, it's the same as the first term. But then to go from 1 over 5 to 2 over 10, we multiply above and below by 2. So we get the equivalent fraction 2 over 10. Then to go from 2 over 10 to 6 over 30, we multiply above and below by 3. So we see that we go from 2 over 10 to the equivalent fraction 6 over 30. Then from here, we multiply above and below by 4 and we see that we get to the equivalent fraction 24 over 120. So what do you think should happen next in the pattern? Simply, we multiply with the next multiplier, which is 5. So we multiply above and below by 5 and this gives us the equivalent fraction with 120 in the numerator and 600 in the denominator. So the next fraction in the pattern will be 120 by 600. So that concludes this lesson and all our problems on equivalent fractions. Thank you for watching.